Hello and good afternoon, and welcome to the Basements Waterproofing webinar by Safeguard Europe. We're now set to kick off. I hope everyone can hear us clearly. This webinar is an overlook at how to waterproof a basement in buildings. It should be an interesting talk, and we'll look to clear up any mysteries on the documents and processes used in basement waterproofing and specification work. To introduce the people here, I'm Michael Pryor, who will be moderating, and alongside me is Damien Wallace, who will present the talk. It will take approximately 50 minutes to present, and at the end of the talk we've allowed 10 minutes to answer any questions. There is a link below in the YouTube description where you can submit questions during the presentation. Okay, well that's enough from me. Over to you, Damien.
Brilliant, thank you, Michael, for that kind introduction. Basement waterproofing. Before we dive into the depths of structural waterproofing and all its associated documents, just a quick bit about us as a company, Safeguard. Established in 1983, primarily involved in the manufacture of materials for damp proofing and timber preservation. Since then, we have become involved in structural waterproofing, distributors for Vandex and Oldroyd, structural waterproofing material supply manufacturers, as well as other associated areas regarding kind of remedial treatments of buildings against the effects of dampness. In kind of developing our company over the years, we've kind of put ourselves in a position of market leader in the UK for the particular industry we're in, remedial treatments. And I think what has set us perhaps aside from other similar manufacturers is that we have a dedicated team of research chemists that obviously, as well as manufacturing, making sure that we have quality control of the materials that we manufacture. We also have a kind of dedicated team towards the research and development of newer products as well. So, as well as having various academic collaborations as well, in particular the University of Portsmouth, we are also involved in export of our materials as well as import. We export to well over 18 different countries across the globe. Okay, some of our brands, top to bottom, from Dry Zone, Storm Dry, Dry Base and Roxil and Soliguard are the kind of remedial treatments and timber treatments that you might be familiar with. Oldroyd and Vandex are the structural waterproofing brands that we distribute for. Oldroyd being the cavity drainage membranes, and if you're not familiar, we'll go into those in a second. And Vandex being more the cementitious or more traditionally generally known as tanking slurries and associated products. Okay, so the propaganda out the way, now on to kind of today's overview of the seminar. What we're really going to be looking at today is kind of the main guidance documents which kind of relate to structural waterproofing to ensure that your basement design and installation is both effective and compliant. We'll be looking at the evolution of basement waterproofing over the years, and also waterproofing design solutions and materials which can help you achieve those designs. And of course, of great importance to specifiers, managing design liability. Usually that's where there's an audible cheer from architects, which means they can sort of sidestep design liability by putting that aspect into the hands of consultants or specialist contractors. Okay, so let's have a look at these waterproofing guidance documents. BS 8102 is the kind of core document for structural waterproofing in the UK, and anybody involved in any way of sort of design of waterproofing systems should be familiar with its contents. And while it's not a legal requirement, there would definitely be kind of, you would be considered negligent if you were to kind of provide any waterproofing design system without considering this and following guidance provided within it. First published in 1990 and revised in 2009, and I think we are due very soon for an additional revision, which should be out later this year, hopefully. And some of the points in it are kind of the different types of waterproofing systems, consideration of water pressure, the head of water pressure, and levels of performance, which we'll dip into a bit later on. So when we talk about basement waterproofing, most people will kind of respond, you know, when you ask them sort of what do you want from a waterproof base, you know, a basement, you just want it to be dry. But how dry is dry? And this is where, as a starting point for a discussion, very often we will kind of say to people, okay, so you've got a basement, a structure below ground. What is it to be used for? And thankfully, BS 8102, we do have this table which gives us some guidance to performance, where you can see 1 through to 3. And sort of by example, a basement car park situation, level or grade 1. This would be the structure itself is holding back a certain amount of moisture, but damp patches would be tolerable. A certain amount of leaking might even be tolerable. But certainly if you were to turn that into kind of habitable space, that's when you would be taking it through to an environmental grade 3. And that's typically where most people are going with kind of basement design, particularly conversion of spaces or development into offices, etc. And somewhere in between that, we have a grade 2. Now, the main performance levels being, whereas a grade 1 scenario, like an underground car park, could be leaking, it could be damp without any kind of effect on its use. A plant room, for example, or workshop might require a drier area where it might be damp in terms of humidity, but certainly no water penetration should be accepted. And finally, with grade 3, this is where we go from taking the performance level of a grade 2 situation, so no water penetration, no moisture vapor, or moisture vapor should be controlled internally by ventilation, dehumidification, background heat, air conditioning, etc., appropriate to the intended use. So a very simple basement conversion, turning a cellar into an office space, it might not need very much promotion, whereas a kitchen for a restaurant that's down in the basement might require quite a specific system. Okay, so with regards to the UK approach to basement waterproofing, it's very much a belt and braces approach. And it's evolved quite considerably since the 1990s, where these kind of systems started to kind of really come into play. So as we're seeing more kind of popularity of basements, both new build and conversion in kind of commercial and residential buildings, there's as we see a kind of an increase in kind of maximizing land use. There is a kind of an approach which is much more it's much more comprehensive and risk mitigating by including as much water, trying to get as much basement out of the water as possible, redirect any water that manages to seep in towards a sump and pump to be removed from the structure. Okay, also in BS 8102, we have reference to waterhead assumption. It should be kind of considered. Probably best advice I would say is in line with NHBC chapter 5.4, a document that we'll look at a little bit later on in more detail. I think I'd stick with that advice. Generally assume exposure to the full height of water during the design life of the building. BS 8102 does give you options that kind of refer to a sort of low or variable water table based on hydrogeological reports to kind of design around that scenario. I think NHBC chapter 5.4 probably got it better, where they kind of just assume the worst. There's no point in kind of doing this by half measure. Assume the water will come to bear to the full height of the structure and design accordingly to prevent any issues, change in conditions externally which might affect the level of water table in the future of design. Okay, BS 8102 also refers to waterproofing types, which there's kind of turned into like 3, type A, B and C. A and B both seek to physically hold back water, with type A being more of a barrier type system, what we might traditionally call tanking. Type B is a structural integral protection, so this is where the structure itself is designed in such a way that it resists water passage. And type C finally is more of a management system, where it kind of manages the anticipated ingress of water and directs it towards a suitable drainage system, which would predominantly be a sump chamber with a pump installed. So with type A, barrier protection, we can see it being applied on external application. We can see it applied in a what's referred to as a sandwich waterproofing, or finally an internal application. So the external side will be what we call a positive pressure situation, whereas on the inside it's what we call a negative pressure situation, which we'll go into in a second. Sandwiching in between, in this kind of, as you can see in this diagram here, is not often very used in kind of in more kind of modern buildings, because guidance documents will require access for repair, and this system in no way provides any way for that to be achieved without causing a bit of destruction to the design of the building. The systems are very often cementitious, but also there are kind of liquid applied products which can also be used as well, or even bonded sheet membranes as well, and they would still be considered as type A systems. As we can see in these photos, cementitious applied by a trowel, bonded sheet membranes in the centre there, sprayed application of crystalline active slurries, liquid application, application of crystalline active to shotcreted pile walls. So going into a little bit more depth with type A internal applied systems, when you are kind of using a barrier system on what's called the negative side of the structure, there are demands placed on the structure which need to be considered. And as much as tanking is more generically used as a phrase, what we would say is that you do need to consider the substrate and its ability to withstand any water pressure that comes to bear on it. So not only does the product itself need to be suitable that you use, but also the condition of the substrate. So surface preparation in this kind of application is absolutely key to a kind of a successful application. Certainly in kind of old Victorian conversions, for example, this might be something that you really want to have a look at, making sure that the substrate is suitable for this kind of application. Concrete, for example, relatively new blockwork, not a problem at all, but do consider the substrate on this application. And if you have any doubt about its suitability, obviously ask the manufacturer for further advice on whether it should be used or not. Another example of a type A system, crystalline active slurries, and these, I should say from the offset, these are for concrete only, poured concrete, not block work, because you'll have mortar joints, so this is for a concrete structure only. And effectively what you have, as you can see in diagram 1, the structure is made from new concrete. And what we have is a crystalline active slurry, where we have the actual kind of granules, the kind of aggregate, if you like, of the concrete, which certainly has a certain amount of pores, which will allow moisture to transfer and vapour. By applying these crystalline active products, what we get now is a reaction between the free lime, which is resident within the concrete, and the actives which are in the product itself, and we get a reaction which allows for crystalline complexes to grow within and around the aggregate and into the pores surrounding the aggregate as well. These crystalline actives then restrict the passage of moisture, but still allow vapour to pass through. Often used with cavity drainage systems as well, as a way of mitigating the kind of the growth of free lime in new concrete as well. Often favoured on new build structures as well, because the coverage rate with these particular products tends to be very generous, because they don't go on as a layer. They are very wet to the mix and kind of spread very, very easily and very generously.
So for just cutting a little bit, David, so for these type of products, you're able to apply them by spray. They could also be painted on, but also if you wanted, you could dry sprinkle them. So that's quite useful, sort of like, different types of usage depending on the area that you're trying to use.
Yeah, certainly this is a product that's very wet mix, as I say, so this is not something you're going to put on a hawk and a trowel to get onto the wall. This is, as you can see in the photo, for typically spraying or brush applied, much more basic but still very effective. But certainly, yeah, if you have a fresh green slab, shall we say, where it's kind of lots of moisture is still present, obviously a lot of free lime, this product can be sprinkled on literally as a powder onto the substrate, and floated into the surface, and you will get the same reaction between moisture content and the free line present within the concrete to form a reaction. So, okay. Type B systems. So these are structurally integral kind of protection. So effectively the structure is doing the waterproofing. And this might be concrete, which is designed to a particular recipe, for want of a better word, and strength to be waterproof, typically in accordance to BSEN 1992 Part 3. It won't be vapor-proof, but it will be kind of waterproof, assuming that all kind of construction joints and details are accounted for. As we can see in these diagrams on the right-hand side, there are ways. It can be expensive in terms of kind of the process, the supervision, the addition of extra steel possibly can have a cost impact. But construction joints, day joints, still need to be sealed as well. So consider water stops, hydrophilic strips, which kind of react with water content, comes to bear to swell and prevent moisture from passing through construction joints. But also design tips like adding in a kind of a kicker to the upstand, as we can see on the diagram on the right there, the top circled, to bring the joint up off of the slab level to just prevent water. I've seen this a few times happen where water collects on the toe of the slab and tracks across through that kind of horizontal joint across. By introducing a vertical kicker to it, it kind of restricts that possibility from occurring. So with type B protection, there are kind of the two main types of kind of using concrete with admixture or using concrete without mixture, but designed to a certain specification to ensure that it doesn't kind of give you any failure. Again, reiterate, kind of the construction joints are the points at which there is going to be problems. Hopefully anybody kind of engaged in this kind of work will have a good company, a good reputation to be able to kind of provide a supervision of the additives to the concrete or the recipe being mixed, but making sure that the concrete quality installed is of the standard that it is supposed to be, and that it's poured correctly on on site as well, properly vibrated out to make sure it is in contact, wall onto slab, etc., to ensure construction joints are managed properly. The reference documents that you probably want to go to, as well as BS 8110 or EN 1992 Part 1 and 2, is also EN 1992 Part 3 as well. Code of practice for design of structures for retaining aqueous liquids. There'll be a heaps more information on there if you decide to go down this route for your basin. And Type C systems, quite a kind of a simple process, originally applied externally and still is, often with a kind of a geotextile backing to it to provide a drainage layer on the outside of new basements. But predominantly now it's kind of most popular for refurbishment projects. And effectively we have a sort of a cuspated or dimpled plastic membrane which provides a drainage layer to both kind of walls and onto the floor. As we kind of might see in this diagram, it's kind of water is allowed to kind of collect to the lowest point into a perimeter channel and run to a sump and pump system where it'll be kind of pumped up to surface drain level. As I say, predominantly used kind of with refurbishment projects, but also used like new build projects where they are used in conjunction with a type A or type B system as what we would call a combination system, which we'll go into a section in a second, which kind of looks at kind of mitigating and minimizing risk in building design. So when you do use type C system, even internally on what we might regard as a more sort of simple basement refurbishment project, we would need to consider the actual structure itself as well. So even an existing basement, as we see advice from a basement design guide from the Basement Information Centre, the external wall must provide enough resistance to water ingress to ensure the cavity accepts only a controlled amount of water or dampness. Effectively, to kind of summarise what we're saying here, is the structure itself it may be subject to kind of some spot repairs. So even it's an existing basement, but there are areas where water is literally free flowing in, repairs may need to be made to the substrate to ensure what's regarded as primary resistance is achieved in the structure. before the actual drainage system then kind of works on dealing with the residual moisture which will come through the structure then. It's not designed to accommodate land, kind of free draining water from the ground into the structure straight away. The structure offers resistance in the first instant. Just some examples of Type C systems being used. This was in a retail environment, originally installed. Type A system installed in the 60s, had failed around construction joints on the outside of the structure. These joints were resealed using a bandage type system, and subsequently a Type C system was applied on top. I know this was way back in the 60s, but this is why we use combination systems. So, for example, in the event that a Type A system had been applied on the outside of the structure, if they had designed a secondary system like this at the point of design and installation, then if there had been a failure on the outside, the internal installation of a cavity drainage system like this would have managed any water ingress, and you wouldn't have been any the wiser that there'd been effectively a leak. Just more examples of cavity drainage membranes being used in new build structures, Chelsea Academy in London. The perimeter drainage channel was kind of installed or kind of introduced into these systems back in the 90s, and it's kind of it works in a way of often people say, is it like a gutter? No, it's not like a gutter. Effectively, it's like an emergency exit for water. So regardless of what, once the floor membrane has gone down onto the floor, and all floor finishes have gone down, these channels are installed with kind of access points, so that at any time the channel can be made to be free draining. You can flush it through or rod it through to remove any debris, any free lime or fines, to make sure that regardless of the situation underneath of the membrane, that perimeter channel provides a route to allow excess water build up to run into the sump chamber and pump system. With regards to the sump pumps themselves, advice from chapter 5.4 from the NHBC, there should be a primary pump with a secondary pump which has a battery or a generator backup. There should be some audio visual alarm that indicates any kind of failure or issues with the pump system, and the pump should operate automatically. Thankfully, most pumps that worth a while these days do this system. It is difficult to anticipate how much water is going to come to bear against the structure. Generally, industry guidance does err on the side of caution and kind of accept that water is going to come to bear against the structure, and it should be you should have provision to kind of manage a high influx of water at the time. Our colleagues in the Property Care Association are kind of a governing body for the kind of remedial treatment industry, but also including, amongst other things, invasive plant species, but also structural waterproofing, and they have a best practice guidance on a number of issues relating to structural waterproof, including kind of drainage systems. Advice given by them is good advice to go for as well. As an approximate guide, one sump chamber and pump per 50 linear meters of channel. Often people are asked the kind of, well, how many pumps should I need on how many sumps should I install on large projects? That is a good rule of thumb to work by, and that will give you kind of adequate kind of coverage in the event of water ingress. Free lime. I mentioned free lime a couple of times during this presentation, and while it can be managed out by good concrete design, sometimes it's an inevitability. Type C systems are vulnerable to being blocked with free lime, as these rather alarming photos show, and that's that nasty kind of nicotine yellow looking stuff building up, and the coating on that pump in the bottom right photo there. Now with new concrete, obviously free lime, underpin basements as well, we have dry pack systems being used as well. These are all kind of sources where free lime can cause issues with cavity drainage systems, so very often trying to mitigate that with things like crystalline active type C systems can also help to kind of minimise the build-up of free lime. There are other products on the market which may also help you in terms of free lime. Do make sure that maintenance of your pump chamber and your pump channels is carried out as well. The first year is when it's kind of going to be at its worst. After that, it should stabilize out. Okay. So what is free lime? Effectively, calcium hydroxide, soluble form of lime formed as Portland cement hydrates as water runs over Portland cement. Sometimes it's not a problem, it's just a crack in the wall, particularly if it's just the basement car park. However, that bottom right photo does show you it can become a problem in some instances. You can see in this Audi has been subject to free lime just building up on, I think there's a bit of a new paint job required here. Okay, so Type C systems do require maintenance, as I mentioned before. The system is mechanical, so there is some requirement to provide access to the channel so that you can flush through the system, but also into the sump, chamber and pump as well. Always should be tested immediately after installation. Once it's in there, fill it with water, make sure it is fully effective before you start to proceed any more membrane installation. And ongoing maintenance is also of critical importance, often to be able to kind of fully kind of realise your guarantee obligations as well. We would probably suggest an annual, apart from the first year where you might want something a bit more frequent, after that an annual pump service. I would suggest it's a bit like having a boiler installed where they offer you like a 7 or 10 year warranty. The warranty only works if you have the service done. So if you don't have your pump maintenance schedule in place, it could actually void the condition of your guarantee from your waterproofing contract as well. So do check that out. And just a quick note on materials, storage of materials with cavity draining systems. You will often see in the market there is are clear or transparent Type C membranes on the market. A word to the wise, be careful with regards to storage, because it might be on-site storage, it might be with your contractors that are storing it. Transparent membranes do seem to have poor resistance to UV light and can become brittle over prolonged exposure, so either cover them or store them indoors, or you can use, of course, more of a kind of a pigmented or coloured Type C membrane as well. Okay, so there are these wonderful, lovely, complicated tables available in BSM 102, which will kind of give you guidance, a kind of a tick box, if you like, as to the risk associated with your water table, whether it's variable or low or high, and kind of how best to kind of proceed forwards. While these are kind of very helpful, I think very often most people now will kind of supersede these kind of documents by referring to things like NHBC Chapter 5.4, where we would insist on kind of multiple waterproof systems or combination systems to mitigate risk and reduce kind of the risk of failure. Okay, now a word on external basement drainage. These kind of this is when you have an opportunity to apply waterproofing to the outside of the structure. This is obviously what we call the positive pressure side. So there's a benefit to doing these kind of applications. You can provide a Type A system and a drainage layer onto that external application. And very often people will include land drain as well. And all too often, I personally see drawings on my desk where the land drain is situated as we have it in that bottom diagram there, just on the toe. It looks neat, it looks kind of convenient just to secrete it in that corner. However, what is happening here now is that land drain is effectively, especially being surrounded by free draining gravel, is effectively drawing water towards the weakest spot, the construction joint. Ideally, you want to have it in positions 1 or 2 on that bottom diagram, about 45 degrees in line or below the slab level if possible, with appropriate falls to make sure that it drains away from the structure. And also consider things like inspection points or rotting ice to make sure that it is free draining. Usually it's a geotextile perforated land drain, and I'll say, yeah, kind of buried in a bed of I don't know, 40 mil gravel wrapped in a geotextile fleece. That allows water through, but filters out all the fines and sludge and prevents it from blocking up. Okay. Now, construction joints and surfaces, as much as possible, we'd like to minimise them in the design process. And I think BS 8102 refers to this. And also chapter 5.4 certainly refers to this and offers guidance in terms of how best to design out, rather than penetrate through your waterproofing system, design surfaces so they can go up and out of your structure without actually kind of perforating it. Construction joints and so essentially, so construction joints, as much as you can minimise them, you can't completely eradicate them. So there are a number of construction joint options, from flexible tapes, construction joint tapes, which are bedded in elasticized polymer enhanced slurries, hydrophilic strips, physical bars, water bars, which will kind of stop water being able to cross through construction joints in your actual building. Sometimes they are unavoidable though, and you may need to kind of design around them, in which case people like ourselves, experienced contractors, will be able to offer you advice on detailed work like that. Okay, a quick nod to approved document B, fire safety in basements as dwellings, but also buildings other than dwellings as well. We have volume 1 for dwellings, volume 2 for buildings that aren't dwellings. I won't drag this slide out, but effectively there's lots of information in there regarding things like access and egress, kind of protective areas where you can escape from basements, the size of and type of fire doors, window escapes, etc. as well. So do refer to these documents in terms of approved documents in your basement design. Okay. That said, obviously these days, as you can see, there's a technical document which has been a consultation paper that was published in January 2020 regarding kind of, although it's more towards the external walls of buildings and combustible materials, it does suggest that there is going to be a move towards careful choices in terms of all building materials. So it should be noted that obviously plastic drainage membranes are at a disadvantage when it comes to a kind of a waterproofing option in terms of fire protection, and certainly, you know, if you burn off polypropylene and HDPE membranes, they are going to release a certain amount of gases, you know, carbon monoxide and such, and that's where a type A system, which is cementitious base, for example, more of an organic material, is going to have a better fire rating, kind of usually a kind of a class A1. So there are kind of considerations to bear in mind, perhaps not now, but perhaps in the future. You know, certainly we have access to cavity drainage membranes, which are typically used in things like tunnels. We have these basalt mineral fibres on the back of a membrane, which give you very good fire resistance. Obviously, they are a little bit more expensive at the moment, but you can see as things perhaps kind of develop towards the future, the prices of these kind of materials might come down, and suddenly you'll be in a situation where you can manage out fire risk in your design and sort of much more kind of easily in the future. Okay, so improving the basic waterproofing standards from the 90s to present day. Why do basements fail? Certainly over the last 30 years, I've been involved in about 18 of those years. You know, there have been a lot of mistakes made, a lot of assumptions made, and I think thankfully developments of guidance documents has certainly helped kind of improve that massively over the years. And some of the reasons we're kind of looking into now, back in 1999, for example, now anyone involved in structural waterproofing will be familiar with Outwing versus Thomas Weatherald, a kind of a case which set a bit of a precedent really, and typically in this instance a singly applied system was applied to the outside of the structure, and the land drain was situated in a rather kind of high position, and as such, as a result, with a failure in the waterproofing and the position of the land drain, water came to bear in the structure. It all kicked off, legally speaking, went to court. An expert witness was called in to kind of advise on this, and the upshot was that it's not reasonable to expect an externally applied basement waterproofing system to be applied perfectly, and thus fulfilling the contract to provide a dry basement. So a margin for error should be included in the design, and as well as that, the form and feasibility of any kind of remedial work. How easy is it to get to an externally applied system if it fails? Not very, without having to dig it all up and start again. So this is why we have this consideration towards multiple systems, and certainly as a result of the Outwing case back in 1999, the 2009 version of BSA 102 did reflect that systems should either be designed in a way that can be repairable, or that combined protection should be considered, or both indeed. So NHBC kind of added into the mix. So back in 2013, they launched their kind of basement campaign, if you like. And I think what was kind of what they were starting to realise is that there was a cost. Obviously, they have a 10-year build mark warranty on their structures, and they found that between 2005 and 2013, claims relating to waterproofing below ground cost NHBC in the region of £21 million and affected around 890 homes. So about £23,500 per claim. When they looked at this, when they kind of identified some of the areas that they carried out an analysis on the claims and looked for the hotspots, if excuse the phrase, and looked out for kind of areas where problems were kind of repeated, including jointing defects at ground level between the substructure and superstructure, i.e. where your waterproofing stops and your damp-proof course starts, surface penetrations through the waterproofing, wall floor junction, as you would typically expect, podium slabs accounted for 12% of claims, and either a type A or a type B system used alone on projects without any kind of additional protection, with a high or unknown water table to kind of bear on the structure. And effectively, it says here in red, I think the main thing is that often systems are poorly designed and or poorly executed. And I think that was the main thing. So there was a lot of changes as a result of this, and a lot of advice given in this chapter 5.4 document. And so now what we have, to build on the theory of BS 8102, now we have actual kind of practical application and real life analysis, if you like, added on and kind of built onto BS 8102. So combining these two documents together will give you a kind of a good all-round knowledge and solution. Some of the things that they pointed out in 5.4 was the use of a system designer, so should be CSSW equivalent, or CSSW is Certified Surveyor for Structural Waterproofing, so an industry standard. Combined systems should be used, an assumption of a full head of water pressure at all times. Trained applicators as well, so the guys actually installing know what they're doing. Simplicity of design, minimising joints, minimising the design of the building to reduce surface penetrations, etc. And also applying that detailing of substructures to superstructure, and enhanced pumping requirements for Type C systems in the event of water ingress. But these now became mandatory as opposed to advisable in NHBC projects. But again, good advice for other builds as well. The advice on combination systems is obviously, I think what we can see through here, the commonality of it all is that it's either an A or B system, but a Type C system is added to either and or both of those materials. So the C system, the drainage system, is your kind of catch-all in the event of a failure because of an A or B system failing. Okay, so with modern basement waterproofing types, obviously going back to what we were saying before about being a belt and braces approach, keeping as much water out of the building as possible and redirecting towards a sump and a pump. These are kind of typical scenarios. So this is our kind of all singing, all dancing, a new build design. So good simple design, reinforced concrete, combined protection. So we have type C and type A system being applied in here. We have a waterproof hydrophilic strip bar in the construction joint. External geocomposite membrane applied on the outside as well as a crystalline active applied internally, which will add an element of waterproofing and also help to mitigate free line build-up. Just some examples of new builds and refurbishments. The system 2 is what we refer to as the dig out, underpinning of an existing dwelling. So maybe the basement needs to go down a little bit deeper. This is some of the issues we have is obviously the interface between existing masonry, dry pack between the new concrete and the existing masonry, and obviously new concrete as well. Potential for a lot of free line, potential for a lot of fines being pushed through the dry pack as well. So often it may be a case of a type A system applied to help mitigate as much as possible that joint, and then the cavity drainage system to deal with any additional ingress of water coming through.
So just on that system, is it quite common actually to for failure points especially, where the linking of the DPC from the the superstructure down to the substructures, where you get a lot of failures where the sort of like planning and design work hasn't taken that into consideration?
Yeah, certainly. I mean that is a point. But with underpinning in this kind of particular slide and scenario, it's usually what they call the dry pack between where the existing foundations, if you like, are cut back and stopped. The formwork is installed. The concrete is filled up to a point. And there is a point between the two, which is then literally rammed through with what they call dry pack mix, so kind of a sand cement mix, rather unceremoniously installed, and that is in this case the weak point. But yeah, often it is the link between the damp proof course above ground level and the waterproofing. Sometimes that can be kind of not linked, and surface water can run over from the top, if you like, from external level into the building construction and over the waterproofing. Okay, so system 3 is a piled retaining wall. Now, this is something you see a lot. This is where kind of often when people refer to new build and existing basements, they're referring to an existing basement being in an old house to a new build being a hole in the ground and then you build a basement within it. This is the kind of the somewhere in between where it's a new basement being constructed in ground, which is formed by concrete piles. Now these obviously can form the wall structure, so these will actually be embedded into the ground, and obviously you kind of excavate the soil in between a boundary of these piles, and then obviously set your slab at the base of the excavated soil, and then now you've got these kind of concrete pillars which are holding back soil, but they need to be consolidated and built back in and waterproofed to prevent water coming in through them. And this is where now we are looking at a kind of, again, another combination system. So it may be formed concrete against these piles, it may be sprayed concrete against these piles to kind of consolidate the surface, but certainly it's beneficial to apply a waterproofing system or incorporate a type A system into the sprayed mix or the formed mix to kind of prevent any moisture from coming through or water from coming through. And then additionally, because you still will have construction joints, to include a cavity drainage system to manage any water which comes through as a result of either design or installation failure. Okay, so some typical examples of kind of sprayed concrete, and also on the left there you can see kind of formwork being installed up, where they'll probably pour concrete down there to make that surface much more consolidated, where you have obviously soil between the concrete pile formed for the piles. Okay, and finally the system 4, as we record, which is a kind of refurbishment of existing basements. So this might be, you have an existing cellar or basement, you may have very old brickwork which you need to convert this space into a usable space, so free from the effects of dampness and moisture. So this is where often with a type A system, for example, an applied barrier system, this is where you do need to consider the condition of the substrate. Now I've seen basements where it's very soft, crumbly, and you could pick mortar courses out with your fingernail. I've seen other Victorian basements where it is almost as good as concrete, where it's absolutely solid, and you probably have no issues with applying a type A system on. Predominantly though, I think most people would veer towards using a cavity drainage system because it does away with the issues of bonding. It provides a drainage layer so that there is no issues with kind of delamination of materials or interference with contaminants in the substrate. It's very simply mechanically mixed, provides a drainage layer to the lowest point, and the channel runs to your sump chamber. Might be worth your while if you are installing new concrete though to perhaps reintroduce a new slab, to use a type A crystalline active slurry to the substrate to again help mitigate the growth of free lime and incorporating that into your drainage system. So that way you might consider that a combined system as well. Okay, so you can see that kind of quadrangle of photos there. So the top left, you can see the condition of the substrate there. Not brilliant for a type A system. That would have to be cleaned right back to the substrate, considered and deemed to be fit for the application of a product which is going to be subject to water pressure. Thankfully, in this case, they decided that wasn't going to be the perfect subject for this and opted for a cavity drainage system instead. As you can see, the membrane applied to the voltage ceiling, fixed with battens for taking finishes onto. Perimeter channel running around, they're shown in green there, running around the perimeter into your sump chamber. Okay, so those are your main basement types. Now a little look into kind of the basement waterproofing process. Very often this little kind of like linked chain, if you like, is how inquiries might come in. Very often we will have an architect that will kind of look at kind of the design process. They will kind of be looking at making sure that the guidance documents available. Hopefully we're looking at kind of a simple design, a resilient design, reinforced concrete, simple shape, minimal surface penetrations. They will then be looking to use a suitable waterproofing system appropriate for this, or combination appropriate to this type of application. Then this will proceed on to a waterproofing design specialist, where this might also work onto a design consultant as well before finally being installed. So these will be competent and qualified designers, either as contractors or consultants, and they will be able to kind of help put the design together in a more detailed way, which is both sort of compliant and effective. And then this will be forwarded to a contractor to do the installation. And even then, after installation, there is a requirement for a kind of a handover and maintenance schedule to be installed to tick off all the tick boxes for the terms of the guarantee, but also to make sure the system is effective for that period as a minimum of 10 years, which is normally what you get for a kind of insurance-backed guarantee from a specialist contractor. So stage one, designing resilient basements. As again, we kind of looked at this between the combination of BS 8102 and advice in chapter 5.4 as well. A three-dimensional review of a structure and waterproofing should be undertaken to identify any complex geometries which are not readily identified for normal two-dimensional details. This is where things like BIM are quite handy. So looking for structural stability and durability of the structure against things like chemicals, frost action, wet-dry conditions. A whole heap of information there regarding to the actual kind of structure itself, making sure that surface penetrations are minimal or managed, keeping it to a simple shape. All kind of design aspects to be considered, but don't worry, because if your design stage kind of your kind of specialist contractor and design consultant will be able to pick up on these things for you. Choosing a suitable waterproofing system or combination of system to suit the structure, as we looked at with the kind of four main designs that we've kind of identified, these kind of scenarios. And then looking to include your waterproofing design specialist as part of the design team, so someone who is suitably experienced, capable of coming up with solutions that provide and accommodate various project constraints and needs, scheduling and the like, as well as kind of the total kind of brief result as well. And these systems should be designed by a waterproofing specialist. As it says here, designers who've successfully completed CSSW qualification from the PCA would normally be acceptable to the NHBC as well. And so we would see a sort of a sequence like this. For example, an architect might come to someone like us, for example, and say, I see that you do structural waterproofing materials. I've got a basement on my structure. Here's some kind of set out designs, layout designs. Can you give us advice on the best system appropriate to the intended use of this project? We would give you advice, generally free, because obviously what we would do is take that inquiry as a commodity and then forward that to customers of ours, which will be either specialist contractors or even consultants, independent consultants. Both of those will be able to, with the right qualification, will be able to come up for a detailed design for you. The difference being with the specialist contractor, as they're the ones that actually do the installation as well. So when it comes to kind of the end result of the work is either designed or carried out, there would be an issue of a guarantee. A design consultants will obviously give you the design liability, whereas the contractor will give you design and installation liability as well. So thankfully, as a specifier, as an architect, you can sort of breathe a sigh of relief, knowing that that is on them to kind of make sure that they get right, and is then their watch list if there's any failures. I think this just kind of reiterates the kind of the slide that we're looking at. So looking at a specialist waterproofing contractor, so even if you use a specialist designer or just a contractor, these guys will know how to react on site. They will be able to provide cost assessment, risk assessment, working in these different various scenarios, and be able to kind of react to changes in condition on site as well, and ultimately be able to offer you a 10-year insurance back guarantee for the design and installation. And don't forget, when we get to handover and maintenance stage, there is a document from the PCA which is recommended to refer to. Specialist contractors will be aware of these things, and they'll make sure that as they go through the whole design and installation process, they document their work. They'll be able to kind of take photos, video shoots. They will test concrete slab falls, make sure pumps work before any additional membranes have been installed. And they will be able to kind of hand over to you a document to kind of verify all of that has been signed off. A little bit about basement ventilation. Where if we refer back to our kind of environmental grade document, section 3 of grade 3, it does refer to the fact that ventilation, dehumidification, air conditioning necessary, appropriate to intended use. And this is where perhaps on larger projects, more commercial ones or larger domestic ones, you may be looking to include an HVAC contractor, heater, ventilation, and air conditioning contractor to design a system specific to your project as well. And again, PCA guidance documents are available on ventilation for basements, as well as regulations for approved document F in regards to kind of ventilation. Okay, of course, a bit of a watchword for all manner of kind of building design at the moment is minimising environmental impact. Obviously, there are things out at the moment. For example, there was a study by Royal Borough of Kensington and Chelsea showing that embodied carbon in materials used for basement extensions considerably higher than above ground extensions. So as that's unavoidable, what is kind of, or what ways can we mitigate that? What ways can we help kind of reduce that kind of offset? So there are kind of various ways to do it, and certainly there are ways that we as suppliers try to do it, and one of those things is reducing the amount of plastic used in these membranes. So if you do decide to go for used membranes, in terms of recycling waste material, some membrane manufacturers will also allow offcuts on waste membrane to return for recycling. Some will also look at recycling at source as well. So, for example, this is old joined membrane, effectively membrane formed with polypropylene plastic, and recycled content is reclaimed from fishing farms and fishing nets, and it is reground, repurposed as the core layer, if you like, in newly established membranes. I have to admit, Oldroyd have been producing multi-layer technology membranes for some years now, where they use recycled content in the core layer of their pigmented membranes. You won't see this on the clear membrane, but any colour membranes, they use recycled content. Have been doing that for a number of years now, but this is just another step up where they actually reclaim it from the sea. Okay, so just in summary, the things that we're looking at today: designing simple reinforced structure with minimal surface entries and construction joints, choosing appropriate combination systems, whether A and C, type B and C, A, B and C, using accredited waterproofing materials where available. Certainly NHBC will take only BBA approved products. Engage with a basement design specialist and or specialist contractor for installation as well. And make sure that you have that all-important handover document and ongoing maintenance program in place. And finally, that will end up with a insurance-backed guarantee provided for you as well, which I said would be in a period of about 10 years. So, any questions? As mentioned before, if you do have any questions, then obviously feel free to drop them in to us. Certainly, you can put them into the webinar question submission link. Any more detailed questions, if you want to follow up, you can just send them into webinar@safeguardeurope.com. And so, yeah, thank you for your time today, listening to our presentation. And please let us have your feedback via the above email, good or bad. We'll take it either way. Thank you for your time.
Okay, thank you, Damien, for that presentation. Really insightful. Like Damien said, if you have any questions, do send them through with the email address there at webinar@safeguardeurope.com. If you do have any other sort of like inquiries that you want us to help you out with, especially with the basements, we are available to take your calls and any sort of plans or any sort of drawings that you need us to look at. Damien and myself are willing to help out there. But yeah, thank you for that presentation, Damien. Really useful. And yeah, I think that's about it. So thank you very much, and tune in for the next webinar. And have a good evening. All right, bye.